Hey everybody, today we're going to take a look at the comparative and absolute advantage material, and today you're going to have an opportunity to fill out your note packet as well as work through some problem sets. So let's take a quick look at the comparative and absolute advantage and how to solve these problems. Okay, so first thing we're going to do is take a look at the steps in solving the problems for comparative and absolute advantage. All right, so if I were to break this down into a number of steps, what I would do is to analyze the data based on the material provided for me. That is to say, if I were given a question about comparative and absolute advantage, the first thing I would do is to create a table. And we'll look at that today, and I'll show you what I mean by that. The second thing I would do is to input the data into the table. So we create this table. I'm going to input the data into the table. Then I want to determine if I'm looking at an input or an output question. And remember, what we're looking at for that is essentially, is this a final good or service being produced, or is this something necessary to produce that final good or service? Then I want to look at, using a bit of analysis, who has the comparative advantage. So we'll break that down. And then finally, we'll analyze what terms of trade make sense for each parties, and ultimately what each party gains when they do trade. So it's a bit of a sequential methodology when you're trying to determine these problems, but it's not overly difficult, and that's something we're going to look at today. Okay, so we're going to start off today by looking at the very common scenario here that a lot of times is presented in textbooks. And you've got like basically two guys living on an island alone, and you've got a young man and an old man. And of course they have to survive, right? So they got to figure out a way to do that. And the young man is, he's faster, right? He can do everything a little bit faster. The old man is older, slower. So we can analyze this through the information provided. And basically what we have here is that the younger man can gather 60 coconuts every hour or catch 20 fish, while the older man can only gather 20 coconuts or catch 10 fish. And so what we're looking at in this particular question is the analysis of coconuts to fish and fish to coconuts and vice versa for each person. So the first thing I want to do here is to put this information into a table. And as you can see on this slide, we have the young man and the old man, and then we have the production of each of their goods in the table, so coconuts and fish. And I've already put in the information here. So I've got 60 coconuts for the young man, which was what was represented in the previous slide, and 20 fish. For the old man, I've got the 20 coconuts and the 10 fish. And right away, I can see here that the young man has an advantage over the old man. So if I look at this data and I say, okay, who can actually do more? Well, the young man, right? And another thing that we should look at too is this an output or an input question? We'll kind of give it away at the top of the slide here. But this is definitely an output question, because what we're analyzing are the total number of coconuts and the total number of fish that are being provided in the table. So the way I know that's an output is it's represented by the final amount of coconuts and the final amount of fish. But again, I can see here that there is an absolute advantage by way of the young man, because he can just do more than the old man. And so he has an advantage over that older man. Now, the next step is to take this data and to reduce it down to its most common form. So it's a little easier when you look at this material if you look at it as a per unit or one thrower. And so if you're looking at this information here, what you can see is that we've got a number of coconuts and then a number of fish that are being produced by the young man. And essentially what this is saying is, for every 60 coconuts that this guy goes and collects, it costs him something, right? It costs him some fish. And so how many fish does it cost him? Well, it costs him 20 fish every time he goes and collects these coconuts. So the cost in total, based on the numbers for this young man, the opportunity cost, are the 20 fish, right? If he collects those 20 coconuts, it's going to cost him 20 fish. If we were to break this down and say, like, how many does this cost per unit? Well, we could do that through a little division. Okay, so I'm going to say, all right, look, I've got 60 coconuts and or 20 fish. And so then I'm taking that number and I'm basically reducing it down to its most common form. So for every 3 coconuts, essentially, is what we're saying, it is going to cost him 1 fish, right? So it's basically saying the same thing. For every 60 coconuts he collects, it costs him 20 fish, or for every 3, it costs him 1, right? And so therefore, for every 3 coconuts, it costs him 1 fish, or 1 fish costs him 3 coconuts. It's kind of either the way you want to look at that. The way that we determine comparative advantage is through a method, and the method is going to be contingent upon whether or not you are looking at an input or an output question. So if I'm looking at an input question, I'm going to use a different method than I'm going to use if I'm looking at an output question. We've already established that this is an output question. So how do I solve this problem? Well, basically, I'm going to use what is called an Ogo method, or output, other goes over. Again, Ogo, the O stands for output, and then the G and the O goes over. So output, other goes over. And really what you're doing is you're just utilizing a ratio, okay, of one to the other. So the way that this works is we're going to be looking at per unit opportunity cost. I'm going to take this number, 60, and put it over 20, or 20 and put it over 60. So let's go ahead and fill out this information here as we go. All right, so I'm taking the 20, and I'm going to put it over the 60. And over here, I'm going to take the 60 and put it over the 20. On this side, I will put the 10 over the 20, and then the 20 over the 10. So again, we're using this output method. Other goes over. Other goes over. Then we just reduce down, right? So 1/3 over here is 3. 1/2 over here is 2. And then the next step is basically to analyze, like, what is this 1/3? What is this 1/2? What is this 3? What is this 2? Well, again, it's all about per unit opportunity cost, okay? And so when we're taking a look at per unit opportunity cost, we're basically saying how many of one item does it cost as I produce one of the other? I should say, how many fish does it cost me every time I choose to focus on coconuts? Or how many coconuts does it cost me every time I choose to focus on fish? So what this number here is, this 1/3 or this 1/2, this 3, this 2, is the opposite item from what is above it in the table. So in other words, if the young man chooses to focus on coconuts and he produces 1 coconut, well, that's going to cost him 1/3 of a fish. Likewise, if the young man catches a fish, it's going to cost him 3 coconuts. Over here, the old man, if he focuses on coconut collection, it's going to cost him 1/2 of a fish. And if the old man goes and catches a fish, it's going to cost him 2 coconuts. So essentially, what we're looking at is a per unit opportunity cost, a 1/4, or how many of one costs in the other. Now, what we want these individuals to do is to do what they do best, right? We want them to specialize. That's the goal. And so the young man, what I want him to do is I want him to collect or to catch fish based on what he is best at. And so what I do now is I look at the cost, okay? So the young man, every time he collects a coconut, it costs him 1/3 of a fish, or 0.33 repeated. The old man, every time he collects a coconut, costs him 1/2 of a fish, or 0.5. So 0.33, 0.5. Well, this is cheaper than this, right? It is easier, or I should say less expensive for the young man in terms of opportunity cost to collect the coconut. As far as catching the fish, we look over here and we can see that the old man, it only costs him 2 coconuts every time he focuses on catching fish. So for the old man, this is cheaper in terms of fish catching, in terms of coconut collection. So this is a little bit more cleaned up, and if we look at these numbers, we can again see what it is that we're trying to accomplish by analyzing the data. And you can see that, again, the young man, there's a cost every time he collects 1 coconut, or per unit opportunity cost in terms of fish, and similar to the old man, every time he catches or collects a coconut, it costs him some fish, and vice versa, fish to coconuts. So what we really want is we want the individual to produce the item that they do best with the least amount of cost, or to specialize. So if I was to like circle these, again, I would just kind of circle this like, hey, the young man, he should focus on coconut collection, and the old man should focus on fish catching. Another way you can look at this, if it were a little bit difficult to look at it in terms of opportunity costs, is to change these into dollar signs. So let's take this side of the table because it's a little cleaner. Let's say that for every one fish, instead of saying this costs 3 coconuts, let's change it into dollars. And instead of saying, again, at 1 fish for the old man costs 2 coconuts, let's change it into dollars. So if we look at it in terms of dollars and say, all right, well, 1 fish costs $3 for the young man to produce, and the old man, 1 fish costs $2, well, we can see that it makes more sense for the old man to focus on fish production because it's cheaper for him, right? And then flip it over here to this side, you've got decimals, or 0.33 and 0.5. We'll change these into dollars. So 1 coconut costs 33 cents. 1 coconut costs 50 cents. And so we can see clearly that the young man should be focusing on coconut collecting. So that's another way you can do it, as a bit of just kind of a trick there. All right, so let's summarize the old man, young man situation. Basically, we have the young man with a comparative advantage between the two in terms of collecting coconuts because his cost is lower. And the old man has an opportunity, or has a comparative advantage in fish catching because his cost is lower in terms of coconut collection. So again, when we're looking at this table, we're saying, okay, the young man, if he focuses on coconut collection, how much is it going to cost him in terms of fish? The old man, if he focuses on coconut collection, how many fish is it going to cost? And again, you can look at it this side too. 1 fish is going to cost a certain amount of coconuts for each of these individuals, and who can do it cheaper, right? That's the ultimate thing we're looking at. So step 1 is to really input this data. And step 2 is to determine if it's an output or an input question. In this example, we're looking at the total amount of something, fish and coconuts, so it's clearly output. Then you have to analyze the comparative and absolute advantage of the situation. So really, more importantly, comparative advantage in this case. Okay. Let's go to an input question. So what makes this an input question? Well, it's an input question because this is the number of hours, right, in this particular table. It's the amount of hours it takes to produce 1 coconut or 1 fish. Again, it's the amount of hours in the table. So if we look at these numbers and say, like, who's faster at production, well, we can see the young man can do both items faster, right? He can catch fish faster. He can collect coconuts faster. The young man has an absolute advantage in both of these things as a result of the fact that he can do both faster. So it takes him 1 hour to collect coconuts, where it takes the old man 3 hours. It takes him 2 hours to catch fish, where it takes the old man 12 hours. But again, we're not looking at absolute advantage. We're looking at comparative advantage. So what we want to be able to do is to compare these two and see who should do what based upon their specialized skill. Okay, so with an input question, we're going to use a different method, and that method is going to be the other goes under method, or what we call the Iou method, or the input method. So for output, it was other goes over. For input, it's other goes under. So instead of saying I'm going to take 1 and put it over 2, I'm actually going to take the 1 and put it under the 2, right? And instead of saying 12 over 3, I'm going to take the 12 and put it under the 3. So it's just a little bit different in terms of what we're doing, but it's the same sort of rationale. It's creating ratios. So just kind of remember that. If it's an output question, we're going to use the Ogo method. If it's the input question, we're going to use the Iou method. Okay, so the way this would work out is we would take the 2 and put it under the 1, so it'd be like 1/2, right? And then over here, we put the 3 over the 12, or the 12 under the 3. Over here, we put a 2 over the 1, and then 12 over the 3. And then we just reduce down. So 1/2 over here would be 1/4, 2, and 4. And what we're looking for is, again, the least amount of cost for each of these individuals. Okay, the method is the same in the sense that we look at it like a per unit opportunity cost. So 1 for 1 coconut for a certain amount of fish, 1/2 of a fish, 1 coconut for 1/4 of a fish, 1 fish for 2 coconuts, 1 fish for 4 coconuts. Again, I'm looking for who can do it with less cost. So in this case, the old man, when he produces 1 coconut, it only costs him 0.25 of a fish versus 0.5. So he should be focusing on that endeavor. For the fish collecting or catching, it costs 2 coconuts for the young man versus 4 coconuts for the old man. Clearly, this is cheaper for him to produce. So again, comparative advantage, we're looking at who can do the one task with a cheaper or least expensive opportunity cost. Now, we could have made these dollars again, like we did before, and that might help when you look at it, like saying, a certain amount of dollars for each one of these fish, like $2 versus $4. Well, $2 is cheaper than 4. So the young man should definitely be producing the fish in that case. Okay, so when we look at the output method, we're taking the other goes over. When we're looking at the input method, we're taking the other goes under. And again, just kind of clean this up to look at it here. We really want to look at it as a per unit opportunity cost. 1 for how many, 1 for how many, and then comparing. Once we do that, we can see who can do it cheaper. That's the ultimate goal, right? Okay. Now, here's a couple more examples we're going to do together, and then we're going to stop, and I'm going to allow you to do some on your own in the packet. But here we go. We have another scenario. We've got Canada and Mexico, and they are considering the trade of 2 goods. Canada can produce 100 firs or 100 trees. Mexico can produce 50 firs or 200 trees. So step number 1, let's go ahead and input the data, right? So Canada is a 100 over 100. Mexico is 50 for every 200. Now, so step 1, let's put the just raw data in there. Step 2, let's determine if this is output or input. Well, this particular example is an output question, right? So what I'm going to do is use the other goes over method, like 100 over 100, 100 over 100, 200 over 50, 50 over 200. Okay, so let's go ahead and plug those numbers in. Now, once I've got that, then I'm going to go ahead and reduce down to the least common form, or let's go ahead and break down these ratios, right? And for Canada, it's pretty easy. It's a 1 for 1, right? So for every 1 tree they produce, it costs them a fir, and for every 1 fir, it costs them a tree. For Mexico, for a fir, it costs them 4 trees, and for a tree, it costs them 1/4 of a fir. So remember, the trick to this is whatever is here, the opposite thing will be in the box or in the row, right? Whatever is here, the opposite thing will be here. And sometimes on the AP exam, they'll give you this table, and sometimes they won't, right? You'll just have to figure this out based on what we've learned in class.
Okay, so our first example here is for Canada and Mexico. And Canada and Mexico are considering the trade of 2 goods. And so Canada can produce 100 firs or 100 trees, and Mexico can produce 50 firs or 200 trees. And so the first thing we're going to want to do here is to input the original data. So we'll go ahead and select Canada here, and we know that Canada can produce 100 or 100. And remember, it's all about opportunity cost. So if Canada chooses to appropriate 100 fir or to allocate their resources toward 100 fir, they're going to give up those 100 trees. And if they choose to go out and cut down 100 trees, they give up the 100 fir. So for them, it's clearly a 1 for 1, and it is also what we would call proportional or cost and opportunity cost. All right, for Mexico, they can produce either 50 firs or, given the same amount of time and resources, 200 trees. Now, when we look at this question, the first thing that we're going to want to do is determine if it is an output or an input question. Well, looking at it, we can see that within this table is the total amount of firs or the total amount of trees. for each one of these countries. So in other words, how many trees can they actually produce? Well, that's an output question. And so what you're going to want to do is use the other goes over method. So take numbers from one column, put them over the other column, and vice versa. Okay? So this one's easy. Canada, we're going to go ahead and just put 100 over 100 and 100 over 100. So again, that one's fairly easy. For Mexico, we're going to take the 200, that's going to become our numerator, and put it over 50, our denominator, and then vice versa on this side. Okay. Now, again, the goal here is to reduce these down to their most common form. So 100 over 100 is very easy, obviously. Breaks down to 1 on both sides. And then on this side, 200 over 50 reduces down to 4. 50 over 200, 1/4. Okay, now, again, the question is, what is it that we're actually looking at? Well, remember, whatever is in the above portion of the table is going to represent what they are producing per unit. So like 1 fir, 1 tree. And what is below that is going to be the opposite. So if we're looking at Canada and their production of 1 fir, then right here would be 1 tree, okay? And again, if we're looking at 1 tree over here on this side of the column or this side of the table, the opposite would be below it. So every time Canada produces 1 tree, they give up 1 fir. And again, for Canada, it's a 1 for 1, so that one's real easy for you to analyze. Mexico, every time they put their resources toward fir production, it costs them 4 trees. And for Mexico, every time they go and cut down a tree, it only costs them 1/4 of a fir. So what we're looking at here is the comparative advantage, or we're looking for the comparative advantage based on opportunity cost. So what I want to look for is who can do what with less. All right, so let's take the left side of the column and look at these numbers. So clearly 1 is less than 4, right? So for Canada, when they go out and collect a fir, it's only going to cost them 1 tree. And comparatively, or compared to Mexico, which it costs them a whopping 4 trees. So we don't want Mexico to focus on fir production, right? We want Canada to specialize in that area because the cost for them is less. Now remember, you can change these into dollars if that helps, and that makes it a little easier to analyze just intuitively. Like for instance, we'd say, okay, for Canada, if they produce a fir, it only costs them $1. For Mexico, it costs them $4. That's too much money relative to Canada, okay? Now, coming over here, analyzing the tree production, it only costs Mexico 25 cents, essentially, to produce the trees, whereas for Canada, it's a full $1. So we really want Mexico to focus on that. All right, now we break this down below, and let me go ahead and clean this up a little bit. So we've got our numbers here, so you can look at that maybe a little cleaner. There's the costs. Okay, so again, it costs Canada 1 fir. For every tree it produces, it costs Mexico only 1/4. It costs Mexico 1 tree for every fir it produces. It costs Mexico, or I think I said Mexico, it costs Canada 1 tree for every fir it produces. It costs Mexico 4. So again, comparatively, who is it cheaper for in the production of the goods and services? Therefore, Canada should focus on fir production, while Mexico should focus and specialize on the production of trees. And then these two parties should trade. And what we're going to look at in a following lesson will be what the terms of trade should be, like how much should they trade one good for the other, and then what are the gains they incur as a result of the trade. But that's not for today, okay? All right, now let's look at one more, and then you guys are going to do a couple of questions on your own. So here we have the United States and China, and they are in the production of cars and cheese. And what we're looking at here is the hours per each one of these things. Like how many hours does it take to produce 1 car or 1 ton of cheese? So in the table below will be the hours necessary. And so right away, light bulbs should be going off that hours is a resource, or just like kind of like land, labor, capital, it's a resource. And so if we're looking at resources, now we're looking at inputs, not outputs, okay? So let's go ahead and throw this in here. It takes the United States 15 hours to produce a car. it takes the United States 5 hours to produce a cheese or a ton of cheese. For China, it takes them 4 hours to make a car and 2 hours to produce a ton of cheese. So right off the bat, I can see that China has an absolute advantage because they're just faster and everything, right? But that doesn't mean that these two parties won't be trade partners, okay? They still will most likely trade, just depends on comparative advantage. Okay, now since we are looking at an input question, we know we have to use a different method. It's very similar in the sense that you're finding ratios, but we have to use the Iou method, which the I stands for input, other, under, okay? So now instead of taking the 5 and putting it over the 15, we're going to take the 5 and put it under the 15. And instead of taking the 15, putting it over, we're actually going to put it under, okay? So that's how we're going to set this up. All right, so let's break this down. So we would take the 5 and put it under the 15, so that breaks down to 15 over 5. We'll take the 15 and put it under the 5 over here, so that's 5 over 15. Then we'll take the 2, that goes under the 4, and then the 4 goes under the 2, okay? So we have our information here. Now again, we just break this down or reduce it down. So 15 over 5 reduces down to 3. 4 over 2 is 2. 5 over 15 is 1/3. And 2 over 4 is 1/2, okay? And so again, we're looking at these as opposite of whatever's up here in the table. So 1 car costs 3 cheese. 1 car costs 2 cheese for the respective countries. 1 ton of cheese costs 1/3 of a car, okay, for the U.S., and for China, costs them 1/2 of a car. Now, all we want to do is look at for who can do it cheaper, okay? Who can do it cheaper? And you can make these into dollars, like I've mentioned, all right? And that helps a little bit sometimes. So for this side of the column, or this side of the table, I should say, we can see that China has a cheaper or a comparative advantage in the production of cars. It's less expensive for them every time they make a car. So 1 car costs 2 cheese compared to the United States where it costs 3. On this side of the table, we can see that the United States can do cheese production for 33 cents essentially versus 50 cents. And so again, the United States has that comparative advantage. All right, let me clean this up a little bit. And we can see the cost there. And so what I want to do is just determine again who has the comparative advantage in each of these. And we mentioned a moment ago, China has a comparative advantage in car production. U.S. has comparative advantage in cheese production. Okay, so that's pretty clear in those particular examples. All right. Now, in the next portion of the lesson, what I would like you guys to do is to go ahead and answer the questions. So you guys are going to do these on your own, okay? And so for pages 4 and page 5, you guys are going to work on those on your own, okay? So go ahead and take a minute, and we're going to pause this video while you guys work on these. And so then what we'll do is we'll go through them after you're all done, okay? So pause the video right now, and then go ahead and work on those on your own. And, you know, if you need some help, you can ask somebody near you. Maybe they can help you out with that. But go ahead and pause the video, and then we'll go over this in just a minute.